last time as to how these things fit into the broader modeling process. I noted that modeling is an iterative process. This is true whether you're dealing with system dynamics, modeling stocks and flows, or agent-based modeling. You've got a series of stages that a model goes through, and there's iteration back and forth. So during model calibration, you may discover issues with your model formulation. You go back and you change that formulation. But broadly, a model becomes more and more well-defined, and more you develop greater and greater confidence as you go to the right here, and you end up using the model in these later stages. I noted that agent-based modeling, in comparison with classic system dynamics modeling, has tended to focus predominantly in the later phases of this. There's just not as much discussion historically on the problem conceptualization side and qualitative mapping. So in system dynamics classic area, you see uses of group model building, for example, participatory modeling, in a way that really isn't been emphasized in agent-based modeling. However, I'm trying to orient the agent-based modeling process using this broad flow because I think it applies very directly to it. The ODD protocol that we introduced last time has a mapping to this process as well. So the overview stage and the beginning of the design concepts phase really relates to sort of these two early stages: problem conceptualization. What are you trying to solve? What are the reference patterns of interest? What is the scope of the model, the boundary of the model? We distinguish three components of the boundary. Does anyone remember what those were? When we try to describe elements that may or may not be in a model, we introduced three categories. Who can mention what those are? There were
endogenous and exogenous and ignored.
ignored.
Which means I can read.
Very good.
I don't want to kick too much.
Well, you'll find me often doing that, and it's a challenge both to remember and to read. So this is exactly right. So the point is to make these decisions consciously. In an agent-based modeling, it's even more important to do it because the flexibility of the framework in describing detailed processes is great. It's very rich. And we have to be very conscious about what we want to put in so we don't end up putting so many things in that our understanding is in fact obscured. Yes?
So I'm wondering how that interplays with when you're actually thinking about heterogeneity of agents.
Yes. Yes.
And you start to think about agents that consider actual different variables in decision making.
Right. So this is a very good question. Broadly speaking, we have to distinguish between issues that we put in structurally versus cases where we have a given structure and we're simply making it heterogeneous. So, for example, this model scope and boundary at this level is predominantly an issue of what variables and parameters, what considerations, as it were, are you including within your model. Now, within an agent-based framework, given a certain set of variables that are captured, say, within agents or within the broader environment, it's very straightforward within the local environment. It's very straightforward to then make them heterogeneous or homogeneous. That is not a decision which affects the structure of a model within the agent-based context. Let me emphasize that again. In classic aggregate modeling in a stock and flow context, if you want to distinguish different levels of heterogeneity, if I want to break down the population, say, by sex, or I want to break it down by age, or I want to break it down by income level, that actually has material structural impact on the model because I need to introduce subscripts. And those subscripts are defined over large portions of a model. So if we have a stock and flow components of our model that we need to break down across it according to age, for example, that needs to apply across all the stocks there, across all the flows. And so that's a weighty decision. That's a decision that we often will be thinking about earlier in the process because there's a fair bit of work involved in changing it later. In an agent-based context, if you have agents which are associated with certain properties, and I'll use that term to denote both state, aspects of state, things like things that might be changing over time. Broadly, you might think of it as including age, but things like income level might be changing over time, education level, people's weight might be changing over time, and properties would include those. Properties would include things like things that are more parameters, their sex or their ethnicity, what have you. We can very easily introduce heterogeneity into that without modifying the structure of the model. It's literally trivial to do, and we'll see how we do that either late today or in our class next Wednesday. So heterogeneity is less of an issue here. What's more of an issue from an agent-based from an agent-based perspective is the issue of behavioral flexibility or richness. To what degree are you trying to capture, for example, agent learning from their environment? Agent adaptation of their behavior to the environment. I'll distinguish those two later in this lecture. Learning versus simple adaptation. That's something you want to think about earlier because it could have a significant impact on what state, for example, might need to be maintained in the environment. If you want to capture someone's adaptation of their behavior in response to the characteristics of the environment surrounding them, you need to start keeping track of those aspects of the environment. So here, behavioral richness is an issue that we'll have to start thinking about at that point. And what I argued last time was that in an agent context, you'll find that while the models can be can be arbitrarily rich, and we can very easily go down that direction, for the sake of learning, it's often best to wield a very sharp scalpel. John Sterman talks about using model purpose as a logical knife to cut away unnecessary complexity. And you'll find full agreement with that in the agent-based modeling literature. Start simple with a model, build it up step by step, adding in components so that you have some measure of understanding about which component that you're adding in yields which type of behavior that you're seeing. If you start with everything in there, it's very hard to untangle their effects. There's so many moving parts, so to speak, with respect to each agent, with respect to the broader system, that it's very easy to just kind of throw up your hands and say, I don't know where this behavior is coming from. It's just coming from everything. And that's just not a very useful thing when it comes to learning. So the general sense is, look, if you're trying to characterize a phenomena in the external world, start only with those things that you're absolutely convinced it would be ludicrous to examine without them. That you couldn't pass a red face test, and then work up from there in a step-by-step way. Okay, and I have some slides on that which are now posted on the Stellar site, which you might want to check out in that regard. And I'd be glad to talk more about it. So also delineated at this area sort of what are our entities? And entities I included agents, but also aspects of the environment. So in an agent-based context, we often have the environment that's built up into a global environment which affects everything in the model in a kind of uniform way. I argue taxes, regulatory sort of rules that apply to everything in the model, as well as a local environment. Locality is very important to agent-based models. It's one of the big motivations for using these models because it affords us a way of describing how people's behavior depends on their localized perceptions, which is often very important. Research has shown that in case after case, people don't have perfect knowledge of the world around them. Their knowledge is disproportionately affected by those in their immediate vicinity, whether it's spatial or whether it's in a network sense, their sort of set of social connections, for example, will disproportionately impact their ideas. So these early stages here, and then going to qualitative problem mapping, where we're using qualitative state charts to describe people's progression among possible states. We're delineating what our parameters and state variables will be that we're interested in. This, bearing on the heterogeneity issue. Qualitative causal loop diagrams or influence diagrams, which are recognized within the agent-based modeling literature. And you can have some interaction diagrams between agents. How do they interact? How does one agent interact with another? Not in its full detail, but what sort of things by which one agent might influence another. So a hunter in our model might pursue a deer, and might kill a deer, might retrieve it. And so there might be a couple different kind of verbs by which they interact, and we articulate those. And then we define the model time and spatial extent. How broad amount of time are we talking about? I argued last time that this issue of time and space is largely determined by the emergent behavior of kind of capture. In contrast to any time step or spatial step, a sort of size of our spatial environment into which we quantize things. The model time extent and spatial extent is often motivated by the desire to capture effects over a certain scale. To have the intergenerational effects really show their face, etc. So these broad areas have to do with the O in the first part of the D, the design concepts. Later, we're talking about more detail of design concepts, and in the final D, what is known as the details in the entire specification, which have to do with a variety of specifics we'll get to, a sort of grab bag of issues that have to be specified within a model. So we talked last time about the overview, the O containing the model purpose, and I'd include in